students, this video lesson is about simplifying expressions. Expressions are simply a mathematical statement that does not have an equal sign. For these particular expressions, we're going to utilize the order of operations. So my first expression is 5 plus -3 times -2. The first thing I'm going to have to do is multiply the -3 times -2, which is going to give me a positive 6. And then I'm going to add the 5 plus 6 and get 11. As I move on to my next expression, I have -2 times 8 minus 4. And negative times a positive is a negative. And then a negative minus a number. I could really rewrite that as -16 plus a -4. When I'm adding a negative plus a negative, I'm just going to get more negatives. So -20. My last expression on the first line is 2 times 4 plus 5. Well, the 2 times 4 is going to give me 8. And then plus the 5, I get 13. My second line is division. Now when I divide, I'm looking for a common factor, something that can go into the numerator and the denominator. So a common factor of 24 and 72 is 8. I can pick any common factor the two have. Ideally, picking the greatest common factor is the best because you'll get to the end result quicker. But it doesn't have to be the greatest common, just any factor that's common. 24 divided by 8 is 3, and 72 divided by 8 is 9. Now 3 and 9 both have a common factor as well. So I just keep reducing the top and the bottom until I can't reduce it any further. 3 goes into 3 one time, 9 divided by 3 is 3, so 24 over 72 reduces down to 1/3. Now my next one is 47 divided by 0. Whenever I have a 0 in the denominator of a fraction, it's simply undefined. Undefined. And what that means is that it doesn't follow the pattern of all the other division. If I said that that equaled 0, well, 0 times 0 doesn't give me 47, because division is always checked by multiplication. If I said it equaled 47, well, 47 times 0 doesn't equal 47, so it doesn't follow the pattern. Therefore, we just exclude it and we say it's undefined. Under the line, undefined. Now, a negative 120 over 168, they're both divisible by 4. So I can divide the numerator and the denominator both by 4. So 4 goes into 12 3 times, 4 goes into 0 0 times, so I have -30 on top. 4 goes into 16 4 times, 4 goes into 8 2 times. Now, -30 and 42 both have a common factor of 6. I can divide both of those by 6. Give me -5 on top and a 7 on the bottom. My final answer is -5/7. 175 divided by 125, they're both divisible by 5. 5 goes into 17 3 times. 5 goes into 25 5 times. 5 goes into 12 2 times. 5 goes into 25 5 times. So now 35 over 25, they're both divisible by 5 as well. So I just keep dividing common factors from top and bottom until I have no more common factors. 7 over 5 cannot reduce further. Therefore, that particular fraction is reduced as far as it can go. Now we're talking about, we're simplifying expressions that contain fractions. The denominator tells you the size of a shape. So 8 over 21. That means I have 21 pieces and a whole. The larger the number on the bottom, the smaller the size. In order to add fractions, they have to be the same size, or they have to have the same denominator. If they have the same denominator, we simply add the top number, numerator, and then we reduce if we possibly can. 10 divided by 21 does not have a common factor, so therefore it does not reduce. Now 11 over 30 minus 6 over 30, they have a common denominator, so I simply can subtract the numerators. 5 divided by 30 does reduce. They're both divisible by 5. 5 goes into 5 one time, 5 goes into 30 6 times. So this particular fraction reduces down to 1/6. Now, if fractions don't have the same denominator, we have to create equivalent fractions that have the same denominator. So I'm trying to look for a common denominator between 3 and 2, something 3 and 2 can both go into. Well, they both can go into 6. So I'm going to create an equivalent fraction, 2/3, with a denominator of 6. In order to get that 3 to be a 6, I'm going to have to multiply it by 2. So therefore, I'm going to multiply the numerator by 2. 2/3 is equivalent to 4/6. Now, 1/2 needs to have a denominator of 6. If I multiply 2 times 3, I get 6. So therefore, I have to multiply the top number by 3 also. So 1/2 is equivalent to 3/6. Now that I have a common denominator, I can simply add the numerators, and I get 7 over 6, which does not reduce. My last fractions that I'm subtracting, they also need to have a common denominator. And in this case, 3 can go into 15. So therefore, 15 is the common denominator. So in order to make 3 a 15, I would have to multiply it by 5. If I multiply the 3 by 5, I have to multiply the numerator, the 2 by 5. The first fraction didn't get altered at all. 14 minus 10 equals 4, and then I bring over the existing denominator. 4/15 does not reduce, so it's already in its reduced form. Now when I'm multiplying fractions and I have a mixed number, I have to change that mixed number into an improper fraction. I'm going to take the 2 times the 9, which is 18, plus the 4, which is going to give me 22. My first fraction stays the same because it's not a mixed number. So I bring over my negative 5/11. But my 2 and 4/9 became 22 over 9. And then my 3/10 stayed the same. Now that I have everything in improper form or in proper form, but there's no mixed numbers, I can go ahead and reduce. 11 goes into 11 one time. 11 goes into 22 two times. 3 goes into 3 one time. 3 goes into 9 3 times. 5 goes into 5 one time. Bring up my negative sign. And 5 goes into 10 two times. And I can still reduce because the 2 divided by 2 is going to give me 1. So now when I multiply all my numerators, I have negative 1 times 1 times 1, which is going to give me a negative 1 on top. And then on the bottom, all I have is 1 times 3 times 1, which gives me a 3. So this multiplies out to be equivalent to negative 1/3. Again, if I have a mixed number, in order to multiply it to 2 other fractions, I have to change it to a improper. So my first fraction stays the same. That's just going to stay as 2/9. My 3 and 4/7, well, 3 times 7 is 21, plus 4 is going to give me 25 over 7. And then I still have my 3/5. Now I can start reducing any of the top numbers divided by the bottom numbers. So 5 goes into 5 one time, 5 goes into 25 5 times, 3 goes into 3 one time, 3 goes into 9 3 times. Now I have no other common factors from top and bottom, so I'm going to multiply straight across. 2 times 5 times 1 gives me 10, and 3 times 7 times 1 gives me 21. 10 over 21 has no common factors, so it's in reduced form. Now, division of fractions, if I have a mixed number, I still have to change it to improper. So the first thing we do is rewrite it with the mixed numbers as improper fractions. So my 11 over 21 stays the same. And my 2 and 4/9, well, 2 times 9 is 18, plus 4. It's going to give me my 22 over 9. And I still have my 3/7. Now, when I have a fraction divided by a fraction, the number on the right of the fraction, or should I say the fraction on the right of a division sign, is going to flip to its reciprocal. So what I do is I change the division to multiplication and flip the fractions on the right of the division sign to their reciprocals. So my 11 over 21 stays the same. My 22 over 9 becomes 9 over 22. The reciprocal is simply the flip version of the fraction. My 3 divided by 7 becomes times 7/3. Now that I've got it into fraction form being multiplied, I can reduce as much as I possibly can. 11 goes into 11 one time. 11 goes into 22 two times. 7 goes into 7 one time. 7 goes into 21 3 times. 9 goes, let's see, 3 goes into 9 3 times. 3 goes into 3 one time. But look, I have another 3. I can say this 3 and this 3 simply cancel. So now I've got a 1 times 1 times 1 on top. And on the bottom, I've got a 1 times 2 times 1. All of this reduces down to 1/2. I multiply it all out. Again, on my other division problem, the first thing I have to do is change this mixed number to an improper fraction. So, the first fraction stays the same. 3 times 7 is 21, plus 4, that's going to be 25 over 7. I still have my 4/5. Now I'm going to change my division to multiplication and flip the fractions that are to the right of the division sign to the reciprocals. So my 2/9 stays the same, but now I have times 7 over 25. Again, times 5 over 4. Now that it's in multiplication form, I can reduce. 5 goes into 5 one time, 5 goes into 25 5 times. 2 goes into 2 one time, 2 goes into 4 2 times. Anything from top and bottom. Now that nothing can reduce further, I multiply across. 1 times 7 times 1 is going to give me 7. And on the bottom, I have 5 times 2 times 9. I'm going to multiply the 5 times 2 first, which is 10. 10 times 9 is 90. That's utilizing the associative property. Doesn't matter which order I'm using. 9 times 5 is 45 times 2 would have given me 92. It just would have been mentally more challenging. Now, on to the next line. We're going to utilize order of operations. So I'm going to do everything inside the parentheses. 9 minus 15 is going to be negative 6. And negative 6 squared is going to give me a positive 36. Now my minus sign is still there because it was on the outside of the parentheses. It's this inside minus sign that got squared that made it a positive 36. Divided by 4 minus 11. And my next step for order of operations is to do multiplication or division left to right. Well, I have a 36 divided by 4. So I'm going to have to divide that first before I do my subtraction. Now 10 minus 9 is 1. And 1 minus 11 could be rewritten as 1 plus negative 11. Different signs, I really subtract. I have more negatives, so my answer is going to be negative. Negative 10. Over here I have a rational expression, an expression that's in fractional form. So I'm going to do everything in the numerator. My multiplication needs to be done first. So my negative 3 plus 18 just tags along, and 5 times 3 is going to be 15. Now negative 3 plus 18 is going to give me a 15, and I still have minus 15. So my numerator simplifies down to 0. 15 minus 15 is 0. Now I focus on my denominator. I do division first. 10 divided by 5 is going to be 2. 2 minus 7 could really be 2 plus negative 7, which is going to be a negative 5. Now, if I have 0 in my numerator and a positive or negative number in the denominator, that's going to reduce down to 0. You never want to leave it in this fractional form. 0 divided by negative 5 is 0. It reduces down to 0. It's okay to have a 0 in the top. That just reduces down to 0. If it's under the line, that's when it's undefined. My last two, I'm going to utilize the order of operations. I'm going to do everything in my numerator. 3 times 2 is 6, plus 18, all over 4. And then I'm going to do everything inside the parentheses. 18 minus 3 is going to be 15. And I'm still working on my rational expression here. 6 plus 18, that's going to give me 24. So I have 24, and 2 times 15 is 30. 24 divided by 4, that's going to give me 6. Now I have 6 plus 30, and then that's going to equal 36. Please excuse my dear Aunt Sally. That's an acronym a lot of students utilize. Parentheses, exponents, multiplication or division, left to right, and lastly, addition or subtraction, left to right. So my last one, I have large brackets. 3 times negative 8 is going to be negative 24 minus 2 times 3, which is 6. Again, they're both negative. I could rewrite that as negative 24 plus a negative 6, which is going to give me a negative 30. Now, negative 30 plus 10, they're different signs, so really I subtract. I have more negatives, so I'm going to end up with a negative 20. I hope this video was helpful. Have a great day.